This is a video on the Lucid Air Sapphire electric vehicle, one of the fastest production sedans on the planet. It makes 1,234 horsepower. It goes 0 to 100 miles an hour in under 4 seconds and will do the quarter mile in under 9. It also costs about $250,000. And you're gonna see about 60,000 different drag race videos with this car versus everything under the sun. And that's not what this video is about. That's not what this car is about. We're gonna do a technical deep dive into the engineering on what makes this car what it is today, how we got here, and what the future means for electric vehicles when they distill down all this technology and know-how into vehicles that normal people can afford, from cars, SUVs, you name it. This is a video for people that love the idea of electrification as future transport, but it's also designed for people like myself and many other enthusiasts that have fears that every single car is going to turn into a rolling microwave on wheels. And after doing this video, I can promise you there is hope, and we're going to show you some of that. But there's only one way to really comprehend how fast this thing is, and that's to take it to Autobahn Country Club, where we're going to show you what it's like in a straight line, what it's like to set a fast lap time and go sideways, but also the fine print of trying to run a modern electric car flat out.
Does the world really need another car company, that's just gonna cobble technologies together that aren't even their own? I don't see the point in that. I think for a company to have all their own tech and innovate around that, that's a reason to start a car company. And I'm proud to say that's exactly what we're doing.
Over the past 5 years, we've driven over 700 cars, new and used. We've talked to every single brand, or almost every single brand, from engineers, executives, to designers, about the philosophy behind making cars. And one of the things I strayed away from in this time was electric cars, EVs specifically. And a lot of that has to do with the fact that at least some of our domestically designed electric cars, and of course those designed over the pond, there's a level of transparency and honesty that is missing in the design and development of a lot of these products.
And that's due to two reasons. First being, most of the messaging around EV vehicles, at least here in the United States, are led by marketing and PR teams. And a lot of those teams lack the technical know-how or ability to explain the engineering that goes into these products. And the second problem is, of course, a lot of these products don't meet their internal expectations. A lot of these cars, particularly when they're not ground-up EV products, aren't all that good, and they're largely disposable. And the manufacturers who are building and selling these cars aren't honest about it, because why would they be? The difference with a brand like Lucid is they have an opportunity to build a vehicle from the ground up, and they are a new car brand, and they have taken a different approach to it. So when they reached out to us to do a video on the Sapphire, we had a rather large list of technical demands.
When I heard that it was another 1200 horsepower sedan and it had all these numbers and it was $250,000, I'm like, nobody's going to be able to afford to buy this. What can we bring to the table? I'm like, okay, what's the next step? And when we got to California to talk to them, from the top down, from leadership all the way down to engineering and PR, my excitement level was down here, and I think yours was too. And when we got done with this, not even really driving the car yet, we were up here. And that has a large part to do with, this is a company that understood the fine print of what they were trying to do with electric cars. Their limitations, and they were being honest about it. They were very, very transparent about what their car was and what it wasn't, and the future of vehicles. And not only that, the most important thing to me was, it wasn't about the $250,000 Sapphire. It was about the technology that they were pushing, the bleeding edge of, to take all those learnings so they could develop a car that a normal person could buy. And that's what I wanted to tell in this story. I wanted to show that there is really hope, because they proved to me, which is really hard to do, they proved that there are still people in the background that love old cars. And the engineers we worked with loved old cars, and they were trying to inject some of that passion, some of that connectedness of those old cars in a car like the Sapphire or into their future products. And that's why I was so excited when this was done and to tell this story.
So let's hear from some of these people, Mark.
Everything in life is very frightening.
The philosophy at Lucid goes back to 2015, I think, when I first joined. And that was really this idea that we were at a pivotal moment in the car industry. This adaptation to EV was just getting some momentum. And I met Peter Rawlinson, and it was really this thinking of like, how do we get the absolute most out of EV technology, innovate, and then excel at performance, range and efficiency, space and packaging, and this overall new experience that is cutting edge EV. Well, you know, I think in my case, I was already working in Southern California with my prior company, Mazda, and I had several colleagues that had been part of Tesla since the early days. And I got a phone call from a gentleman, Bernie Say, again, a former board member at Tesla. And he explained that he had started a company called Ativa. It was a battery technology company, and that he had also hired Peter Rawlinson, who was the former chief engineer of the Tesla Model S, to join Ativa. And they asked me to come work to develop a car brand. And that's kind of how the whole thing started. We knew the ambitions that we were going after in terms of performance, range, our own technology. We knew that wasn't going to come cheap, right? It was going to require a lot of investment, and it was going to also translate into the price of the vehicle, you know? And that's not like, history tells us often that advanced technologies and advanced innovations in the beginning come at a price, right? So the idea to come at this from the luxury standpoint from the beginning was really first and foremost kind of a business position, that we could do this innovation and bring something truly fascinating and inspiring to market, that then over time we can drive down and bring those the DNA of those technologies to more of a mass market. And I think That is absolutely what we're committed to. The idea is not to only just make expensive cars. We want to bring that down, and we do want to democratize that, and it will happen, and we're already working on that. Yeah, I think from the beginning we wanted to do a very clean, minimalist design. We saw advanced electric technology as a chance to kind of not do the cliches of the internal combustion kind of design era, especially, and I'll give you examples of that. You know, I'm coming off the 2000s where grills were getting bigger and bigger and bigger and bigger, and more fins and more scoops. In some cases, 60-70% of it was fake on most cars. And it was just like, it was reaching a point where I was just like, we have an opportunity with our technologies to flip this, to say, we can give you a vehicle that's quicker than anything, and it's minimal and it's clean and it's bold through that, rather than the other way around. It's rather than being additive, which had been the kind of prevailing design philosophy for probably the last 10 years or so. If you look, especially in the front end of vehicles, we wanted to flip that, and as a result, it stands out for that, and becomes recognizable for that. And I think that was also our contribution to kind of, I would say, electric vehicle design, because others have fallen, that sets some trends that others are kind of following. And trends are trends. These things will evolve, and I'm sure we'll go through a nostalgic period in the not too distant future where we harken back to internal combustion again. But for where we're at right now, I felt like that was the right emotional point. And if I look at luxury sedans in general, they evolve very slowly. You think of these posters that have like 4 generations or 5 generations of a 5 Series BMW or an S-Class, and you see each one's like, well, they just changed a little bit over the, it's evolution. It's a conservative class. So we knew that to have something understated but that did these remarkable things was probably going to appeal to customers that are traditionally buying an otherwise fairly understated and elegant vehicle, versus trying to make it overly showy and perhaps lose a larger audience.
If you spend enough time inside Lucid, they're going to throw the word efficiency around like a ball. And it encompasses so much part of the engineering and design of this car, from exterior, from wheel to tire choice, to aerodynamics, to motor design, you name it. But when you get to the interior and exterior, it's really tangible. Because when you try to build a luxury sedan, a barge like this that has a really long wheelbase, you can make the car big. You can make it cumbersome, where it can barely fit in your garage, or if you're in a city, it makes it hard to park. In the case of the Lucid Air, that's one of the things they tried to address. By shrinking down the exterior, you usually sacrifice interior space and storage. But because clever design from the ground up to make this a dedicated electric car, they were able to think about how to lay out battery cells, how to lay out the modules so they could maximize efficiency of the interior space and shrink down the exterior. And that's exactly what they did. They even set it up in the back where you can remove certain modules to get more footroom for the back occupants. Regardless of that, whether you get the long range or the shorter range, it's irrelevant, because the inside of this, you feel like you're swimming. You feel like this car is absolutely enormous when you sit in the inside. Many models will sacrifice the frunk because they haven't figured out how to package an electric motor up there. That's not the case with the Lucid. When you pop open the clamshell hood, you see there is an enormous amount of space, and it is dual level. The top level doesn't look all that impressive until you remove the cover. What's crazy about it is when you remove the cover, you can fit a full 31-inch style international luggage with a little bit of room to spare. When you get to the trunk, you can see there's a bit more compromise there because of the design of the rear deck. It does have a multi-stage storage solution and corner pockets. One's for your charger if you need it, the other one is for whatever you want. When you pull up the cargo cover, you can see there's a deep well there. Makes sense for groceries or things you don't want sliding around. And the pile of the carpet in the back is really, really thick, much like the rest of the car, and that acts as or doubles as sound insulation for the electric motors. And A lot of that thought carries right over to the interior space, and you can tell by the multiple disciplines of the interior designers and the engineers and the founders of this company where they came from. There's this great blend of understated luxury on the outside and the inside. They said right up front with the Sapphire, they didn't want it to be shouty. It's not a car you drive down the road and people are like, oh, look at that guy, he's rich, or look at that car, that's the fastest car in the world. It just somewhat blends in. In terms of interior design, you can see multiple influences here, and it's a good thing. When you look at the overall dashboard structure, the interior space, the material choice, you can see a little bit of Japanese luxury. You can see German, you can see British sports car here. But the main thing is they've minimized the gimmicks. Yes, there are screens. Yes, there is the removal of many physical controls. But when you look at the door panel, very, very clean, but also not gimmicky. There's still door storage. There is a ton of elbow room and shoulder room and hip room in here. You are floating. Regardless of how you spec this out, it maintains a very clean look. It blends into the background, including most of the technology. Your center gauge cluster is essentially a screen that shows you the bare basics. There's nothing on here that is going to distract you, and that's a good thing. Again, a lot of this is about blending into the background. The center screen below where the center console is the centerpiece of this car's technology, or at least how you control the car's technology. It includes your drive modes from smooth. It has the Sapphire mode, including the battery conditioning mode if you're choosing track or drag strip mode. But what you don't typically see with screen technology is the ability to make it disappear. And that is one of the best functions of this car. When you have everything set up the way that you want, you don't want to be blinded by this or be distracted by it at night. It turns into a storage chasm where you can put whatever you want, your phone, a bag, food, you name it. Storage is not an issue in this car, and the technology always seems to just disappear when you want it to. Yes, they could still use some physical controls, like to adjust the steering wheel, but they have kept some of the core things like a track selector. The quality of the volume knob is very impressive, and the steering wheel on the Sapphire is Alcantara coated. However, the regular car has standard leather, which is very durable feeling. The rest of the functions, like your seat controls are there, although there is physical redundancy on the side of the seat, which is great. You have a massage function, which combines pressure points and inflation, along with vibration, which is going to please certain demographics. Speaking of massage, seating is a big deal. And in this car, they find a really good blend of supportiveness, which is amped up in the Sapphire, of course, but even the regular seats on the Touring and Grand Touring are excellent. They're just supple enough for longer trips, but just supportive enough not to be obtrusive. The back seats are enormous. You could live back there. They are so comfortable. And if you have the non-Sapphire version with the glass roof, if you like solar exposure, you're gonna love it. It does have a huge wow factor, but for the Sapphire, for the sake of structural integrity, they have an aluminum roof. And that's perfect for a more dedicated sporting experience. I really do feel like the interior designers had a good direction of designing this for people that came from traditional cars. They weren't trying to give you a bench design here that like they set up in an office space and then just transport it into a car without testing it. You can see that a lot of these decisions filtered down were made by people that really understood how a car interior should work. Is there room for improvement? Yes, like most cars, but the overall aesthetic of it is very, very pleasing and non-confrontational.
My story with Lucid started in 2015. Basically, I was an engineer in Michigan in a company called ANSYS, developed software, simulation software for aerospace, automotive. My focus was on automotive there. I was settled, had a home in Ann Arbor, Michigan. My two daughters and my wife loved the place, loved the neighbors and the neighborhoods there. But I almost out of nowhere, I got approached by a guy that I knew, and he said, "Hey, I'm going to introduce you to this company." And what is that company? And said, Ativa. And then I Googled, I found the only thing I found, the website is under construction. I was always interested before that to basically at ANSYS, I was just doing lots of simulation, application engineering work. But all that theory in the computer, I was designing motors in the computer, but not in a product. So this idea of translating that theory and knowledge into a real product really fascinated me and triggered me to really pursue that. Although, I mean, I had some companies approach me there really, but I was like, Ann Arbor, ANSYS, my family, and all settled. Let's not make that change. But when this company kind of triggered me and visited the team here, I met several folks, including Peter Rollinson in the interview. And he really, attracted me to the opportunity with his brilliance, charisma, belief in science and simulation. Discussed power curves, torque speed curves with him. And I told my wife, hey, I think we're not going to lose much. We're going to put the house on sale. And she was not, what? Seriously, like, what? And put the house on sale and put my kids in our Toyota Camry. And now I lead powertrain. Feel very fortunate to be surrounded by amazing team, amazing leadership. And that's my story in a nutshell. Lots of ups and downs in between.
One of the other things that I find interesting about this company is most traditional automotive OEMs outsource a great deal of their engineering to different companies, whether it be, you name it, ProDrive, et cetera. You guys have managed to keep that engineering in-house. Why did you do it, and what has it given you the flexibility to do?
Engineering in-house and keeping all the IP and the critical decisions in-house is a great tool to making progress really quickly. And you're self-reliant. Nobody can decide over our fate better than ourselves. And we all fail together or we win together. So the approach of bringing all important engineering in-house, that was out of question, that we would not do that. So with an internal engineering team, we have those experts that I mentioned right at the beginning that know what the best suspension needs to do and the best body structure or the safety aspects and the 12-volt system and the ADAS system. And we can iterate quickly and generate the best product. If we were to outsource big portions like body structure or chassis or an ADAS system completely, then we'd have to specify that out for quite a long time so that the person that is reading your specifications will get it right. So this specification job is an underestimated task, because what one person says is like a conversation. You say something, you have something in your head, and the person that's on the receiving end may interpret your requirements or what you've written down in a different manner. So you are stuck then in loops to recover from those misinterpretations. And that costs speed, which is really a relevant resource for us, time to market. We needed to develop our car with a 3-year into production timeline, which is really, really tight. And in comparison, typically you have a platform engineering and you've got a top hat engineering timeline, and they are disassociated. As you said, it's you essentially align a top hat with a new powertrain, but the powertrain wasn't designed specifically for the top hat, and vice versa. In our case, we had to design the whole vehicle platform, all technology, and the top hat in unison at the same time, which was a great opportunity because we could mold the vehicle around the powertrain and the powertrain around the vehicle, but it's not an easy task because you have to get everything to fruition in a relative short time.
So when I joined, I mentioned there was some legacy work that before me, the engineers who worked with Ativa proposed some induction motor topology was quite similar to what Tesla had back then. And they start questioning why induction motor was their first choice and not, let's say, other architectural designs like permanent magnets with, let's say, high torque density, architecture. Started, with my simulation background, where I used basically, I built those tools. I built the tools like from almost some of them like from scratch to design motors. I was able to expedite that iterations of design. I was iterating around different designs. First of all, you have to detach yourself from the details, because the worst thing we could have done, let's optimize the induction motor. Can we make this better by 2-3%? And we said, let's see it from a clean sheet point of view. What is the right architecture? And those design tools helped us arrive to those best architectures quite quickly with the powerful simulation, science-based engineering tools. And with that, we arrived to an architecture that was, as a first step back then, it's a permanent magnet motor with the oil cooling technology, but was still a random wire. As we progressed, we learned more, and we were courageous enough to embark into new architectural designs in the motor cooling. Again, simulation helped us understand what we call now the dead zone in the motor. We switched our wire or winding system from a round random wire to a rectangular continuous wave technology. I was researching what is the best way how to make a motor efficient, manufacturable, quiet, and thought about that if we do a continuous wave, that would be really the ideal system in terms of winding. And starts looking into, for some companies we've done maybe something like this for alternators or not. We met some folks and we discussed some ideas, and from there we made it into production. We developed a prototype line for the continuous wave winding, and my philosophy, I tell this to my team: respect what others do, don't follow. Understand what they do. So don't be afraid of something new but you have to know the whys, why we do it differently. It has to be better, and better in what sense? What are the attributes we're looking for? And then use science to drive these attributes. Understand the system view. With the system, I speak about systems quite a lot, because a motor by itself is not the best motor unless you put it in the vehicle and performance. So, and it provides the attributes in efficiency, quietness, reliability, sustainability, and so on. So I think the philosophy starts with the thinking of use your science. In the air, I mean, we didn't break the laws of physics, but we approach them smartly, and that means we can really and understand how science can be used to advance the technology and apply it. But also, I would say the other secret, which is probably known for a long time, is that an idea is an idea, and talk is a talk. Drive, commitment, persistence, and that's what eventually brings us success. And I think that's combined. If you have that commitment combined with a science approach to technology, I think is a recipe for success.
Now, you've heard the engineering story, but there are 3 core technologies that made all of this possible that Lucid developed in-house. Now, the first thing I'm going to talk about is their electric architecture, or vehicle architecture, known as LEAP. It's both their suspension platform for the Lucid Air Sapphire and, of course, their battery packs. In the case of the Air Sapphire, they are using their largest battery pack. It's 118 kilowatt hours, and it uses 22 modules. Each one of the modules has 300 lithium-ion cells. They are a cylindrical cell. And the modules themselves are independently monitored, both for battery health and, of course, temperature. When it comes to the cooling solution of the individual modules, they run a water glycol solution through a cooling plate. Each module has its own independent cooling plate. The big issue with electric vehicles when it comes to performance applications is managing temperature, making sure it doesn't exceed its temperature range. And when it comes to their cooling strategy, they took lessons learned specifically from Formula E, where they are the sole battery supplier. The next thing to talk about is the voltage strategy. The Lucid Air Sapphire, because it's using their largest battery pack, is a 924 volt architecture. Why such a high voltage? Well, it comes back to efficiency. If you run a higher voltage, you could run less current. When you half the current, when you double the voltage, you could theoretically quarter the heat losses in the system. When it comes to the Lucid Air Sapphire, they also added a heat pump and changed the battery chemistry itself to deal with the higher temperatures associated with the battery pack due to its performance application. The next technology to talk about is the Wonderbox. It manages all the power flows to and from the battery. It is a structural component of the vehicle, going back to the space concept. It actually acts as a bit of the crash structure. It's located between the bulkhead and the drive unit. And the Wonderbox is what enables the 350 kilowatt fast charging when available. Before I elaborate on the electric motor design, I want to bring up the way they configure the drive units. If you have an all-wheel drive equipped Lucid Air, in their higher trim levels, you have a front and rear drive unit. They are physically identical. However, through clever packaging, they essentially mount the drive unit sideways in the rear of this vehicle. You can get a rear-wheel drive unit, which has a single drive unit in the back. However, for the Air Sapphire, they went with a tri-motor design, which is cleverly marked by a blue inverter cover. In the back, you get two electric motors, one for each wheel. This allows them to truly torque vector both wheels independently from one another, which we'll talk about later in this video. Now back to the electric motor design. There are several key innovations when it comes to technology. Let's start with their stator design. The big thing they developed is their copper winding strategy. They called it their continuous wave strategy, which essentially maximizes their efficiency. The stators themselves have a built-in cooling jacket, essentially, which allows them to run ATF through it to extract heat from the copper windings as efficiently as possible. The next big innovation is their rotor design. The rotor has been hollowed for them to put their differential inside the rotor itself to maximize the amount of space they're using. They are the only manufacturer to do this, and it's what allows them to have such a clever space concept. The motor is as efficient as they could possibly design this thing. It is capable of putting out 670 horsepower.
Yes, before joining Lucid, I used to work at the Red Bull Racing Formula One team in England. I was there about 11 years. I started just before Red Bull took over from Ford. So I started on the last car of Jaguar Racing.
So coming to a street car, a clean sheet street car, talk to me a little bit about like the aerodynamic function or purpose that the Lucid Air was what they were trying to build into this car.
Well, for me, first of all, it was new because I only knew Formula One racing before, so I need to adapt to a production vehicle. But what we're trying to achieve was pretty straightforward. We wanted to have a very efficient vehicle. As you can imagine, the most efficient means the smaller the battery pack can be, or for a given amount of energy, you can maximize your range, and that's what we were working on really to achieve.
The Lucid Air Sapphire, new performance moniker, supposed to be like world class in terms of performance, while still being efficient. You mentioned that, and everybody in Lucid mentions efficiency. It's very important to the brand. So how do you take a high performance car, give it the aero requirements of hitting 205 miles an hour, and then still make it efficient? What was the aero strategy for that?
We had to find an efficient aero devices. So how much, for a given amount of drag they might generate, how much downforce you can get, and paying close attention to the lift to drag ratio. When we developed the Lucid Air, it was not only to minimize the drag, to have the lowest drag possible, to maximize our range. Especially for me, coming from a racing background, I wanted to have excellent high-speed stability. And a sedan, you start with a handicap because naturally, if you look at the side view profile, it's pretty much an aircraft wing, and it will generate a huge amount of lift, and that is the profile of the roof, for instance. So we had already great foundation, but it was not that the car was developing downforce, of course. We're trying to minimize the lift and also have a very good balance between the front and rear axle to have a very good stability at high speed. So with the Lucid Air Sapphire, one is, first of all, when you start fitting the wider wheels and tires, you end up adding lift. Especially we ended up adding more lift on the front axle. So we already had it more lift than we started off with. But then it was really the first thing we needed to do is we really needed to add downforce on the rear axle. Downforce that would really make a difference at high speed. And then it was about how to balance that downforce such that, yes, you're going to have very good high-speed stability when you're, say, on the Autobahn. You don't go too far such that you end up with so much understeer that at high speed you can't correct the trajectory. And also when you go on the racetrack, you want a car you're going to be able to position, be able to hit the apex and go. We look at the rear and we started work on the spoiler. That is, the major contributor to, in terms of downforce, to the overall aerodynamic package. And then how much more can we add efficiently, minimizing the amount of drag, and then balancing the vehicle. But at the same time, we need to look at, on top of that, having a way of decreasing the drag, because if you look at the wheels were developed for performance. So minimum mass and also maximum amount of air going through the wheels to cool the brake rotors. On the rear, you have the wheels, and they generate wakes. Those wakes, you can think about region of the flow right behind the wheels where you take a lot of energy out of your flow, and those, what we call total pressure losses, will wash over the diffuser, especially when you start seeing crosswinds. And what happens is the diffuser is not going to perform as well, and you're going to lose performance. So what you will find on Sapphire, at the rear, we added additional strakes. They don't look fairly large, actually, if you take a look at them, but they are actually, I would say, extremely powerful, and they will bring a lot, especially when you go in crosswinds. The initial thought was to keep the wake, so that lossy flow, out of the diffuser to enable the diffuser to work harder. And what we ended up with is not only generating additional downforce, but actually at freeway speed, we decrease the drag. And the way those strakes work, it's a fairly simple device on its own. If you look at them, it's a simple plate that can be curved, a fence effectively. And the way they work is they create a pressure differential that will drive a vortex. A vortex, sometimes you can see it as a small tornado, but they create a very low static pressure. And the vortex and those tracks effectively not only locally load the floor, those vortices are extremely powerful at managing the flow, and that's what they are doing. If you position the trajectories of vortices very carefully, you can have very beneficial effects. In fact, in that case, you don't have any induced drag from them. The beneficial effect downstream result in a decrease of drag. And you will find on Sapphire, we have also strakes at the front. And the strakes at the front, very similar device, and they work with we have also a front splitter. And what they do is they enable to balance the vehicle. So you're balancing the rear downforce by adding some or decreasing, say, the lift on the front axle to get the right balance at high speed.
Continuing the aerodynamics discussion underneath, when you look at the rear diffuser, it is enormous. In fact, from the leading to the trailing edge of this, the three pieces of it make up 47% of the underbody. That's how large it is. But it's not just about slapping a panel up, and that's what we see on traditional, more commodity sports cars or many cars. It's just afterthought panels that have to be put there. And the thing is when we talked about the holistic design of this car and how other teams work together, and talking to the chief engineer, one of the big pain points was that diffuser couldn't just be there. They wanted a slow ramp of air towards the leading edge of the diffuser. And part of that was physically curving the battery pack. So the rear portion of the battery pack has a curve to it. And that smooths out the air where you can convert dynamic pressure to static pressure in the back. And this is something, when you look at the diffuser all the way to the back of the car, I have not seen any vehicle except exotics where the fitment of the diffuser and all these panels together are unbelievably tight. It looks more race car-ish in terms of fitment. There are not a ton of gaps. There's not a ton of spaces where air can seep and leak off to, and that's the level of detail that they did. Now, we heard over and over again that this was designed, engineered in the United States, built in the United States, that all the design goes under the same roof, and this is a perfect example of how that worked. And this wouldn't have been possible if teams were working in silos. And because the aerodynamic part of this was so critical, they had to be working with the battery team to make the aerodynamics in the rear half of the car work. So these components are all working together, along with suspension building and how you package all of this together. It's a unique design that you don't typically see, and it's exciting to see this level of innovation. The same goes for the rear spoiler, and this is something they wanted to do without creating too much drag. Again, they're trying to find the perfect balance of a car that can be slippery, yet provide stability in terms of downforce, even excessively high speeds of essentially 200 miles an hour. Now, granted, most people aren't going to hit there, but it's not something you want to have as a significant amount of lift. And the beautiful part about this car is they haven't had to go to extremes with having front canards, massive wings, although they did talk about that, but in the end, they wanted a more understated approach, and having the technology and dedication to having the teams work together is how they did it. Now, I spent a good deal of time underneath this car with the engineers and talking about aerodynamics and some of the functions of it. And starting from the front of the car, there is a great deal of stagnated pressure on the front. And to help that, the air curtains or the air vents on the front of the car help to divert air out to reduce that pressure. And also, the lower area of the front bumper is completely smooth. When you look at this, and I'm not kidding you, I've been under hundreds of cars. You look at the attention to detail at how the front strakes are integrated into this paneling. They are not just riveted on or screwed on, they're literally built into it. And those strakes on the front also help to move air towards the back. They actually direct air underneath the entire middle plane of the car out towards the back. And I'm kind of showing you how the air flows out of these and directed through the rear strakes. And all of this is really to clean up the air out the back. Also, when you go to the Sapphire, you have a much larger wheel and tire package, which is almost counterintuitive from their aerodynamic design, the low drag design. So you're creating a much larger wake off the front tires and creating dirty air. So this air curtain also helps to divert air around that. And having an open wheel that helps to get air into the brakes is also another pain point in terms of creating drag. So the solution wasn't to have a separate wheel and tire package. They didn't want to do that. They didn't want to have an efficiency tire and a high performance tire. They wanted a tire that could do it all, and they wanted a wheel that could do that all. And part of that process was to develop a wheel cover, a carbon cover that went over the wheels themselves, that would boost efficiency on the street or on the highway where you're normally driving. And then if you want to go on track, you take them off and problem solved. So you kind of have the best of both worlds, but they did have to validate the fact that putting on these covers or potentially leaving them on track wouldn't cause an aero instability or imbalance in the car. So they went to that level of detail. So let's walk through some of the basics of the chassis tuning. What did you have to do here to elevate it, body control, ride refinement, and all the things that you had to balance?
Yeah. So obviously we added a third motor, which gives us a load more power and a load more torque. But a big thing for us was we're not just going to do that and call it good. We've got to elevate everything on the vehicle together. So we've got some very sticky, bespoke developed Michelin Pilot Sport 4S tires. We've got a new aerodynamics package. We've got retuned chassis, so springs, bars, bushings, dampers. We've retuned all the electronics on the car as well. Things like electric power steering, stability control, brake boost, so much more that we can go into in a moment as well. For us, the great thing was we were starting from a very solid foundation in air, and something that we've developed for the last few years. So we know it inside out, we know how to work with this platform, and it was a great place to start. So yeah, you want to go through a bit of detail on kind of specifically what we changed?
Yeah, sure. So I mean, yeah, for us, I think the car, as David said, the car was about, kind of, yeah, we're throwing another motor at it. We have more power, but we wanted it to all kind of make sense and be cohesive, and that went both in some of the new hardware and the new systems on the car, and also how it was kind of tuned, the philosophy of it. I mean, this was our first the launch of the new part of Lucid, the performance branch, Sapphire, and we want to deliver a car that balances power with the excellent high-speed stability, as well as excellent refinement when you're driving around town. I mean, it's common for performance cars. The performance team gets their hands on a car and they'll lock out the dampers and throw ball joints all over it. That wasn't us. We had just come off of the developing the Air, which was generally lauded for its general balance of ride and handling in the same package, and we wanted to kind of replicate that, but with everything turned up a notch and with a balanced package that made sense.
So to talk a bit more about the foundation we started from, so on Air non-Sapphire, we have essentially a double wishbone front suspension architecture with a split upper and a split lower. So we do that to project our steer axis outboard, very carefully manage scrub radius and hub level offset. When we're dealing with the amount of torque that this thing will put out, it's crucial that we really kind of sweat the details on our geometry. The rear architecture is an integral link, so it's super stiff where we want it to be, laterally and in caster, in braking and so on. But it allows us to put compliance in ways that we want to, as John said, achieve the ride and handling balance. We have a pretty kind of simple, honest setup really in terms of coil springs and adaptive dampers. We went with coil springs because early on in Air development, we looked at, should we go air suspension, should we go coil, should we do something else fancy? And one of the common misconceptions with air suspension, people say, well, a car has air suspension, has this brilliant pillowy ride, it's soft, it's comfortable, it's refined. And yes, they are good, but one of the downsides of an air spring is you're essentially folding a rubber material over on itself as you travel the spring. And with that, you have a friction and a hysteresis, an energy loss into that. And that causes the system to want to kind of resist movement over small amplitude bumps. So your small bump compliance suffers, your secondary ride suffers. If we then look at a coil spring, which has almost zero friction and hysteresis, it's happy to move over the smallest of disturbances. So you get this kind of glass smooth, a boat on glass smooth water feel. And we kind of weighed up that potential ride benefit with the benefits of, another benefit of air suspension is being able to lower the vehicle at speed to reduce your frontal area and therefore be more efficient on the freeway. With the Lucid Air, we have such a low CDA and well, such a low CD anyway. It's already a very aerodynamically efficient car. So lowering it doesn't really give us that much of a benefit. Whereas with air suspension, we would have to expend energy to run an ECU, a compressor, a valve block, and it kind of negated the benefits really. So we said, let's keep it super simple. Let's go for that great ride, and we're pretty happy with where it's come out really.
Now back underneath the car, there are many mechanical changes to the Sapphire. By necessity, you're talking about a very heavy vehicle with high horsepower and a high top speed, along with much stickier tires. Now, one of the first things they had to address was the braking system. So speaking to that, in the front, they have a 10-piston Akebono caliper, and then they have a custom-designed brake disc, long strand carbon ceramic, which is more resilient to heat cycling. It maintains an even temperature under repeated thermal shocks. So the disc itself in the front is 430 millimeters by 40. They're absolutely enormous. They are a floating design as well, and the other interesting design element of the brake system itself is the dust shield, something we never talk about. You can either remove them in the aftermarket, but in this case, they developed louvers in them to help create a vortex. It's to bring cool air into them as the discs spin, again, keeping that rotor temperature more consistent across the entire surface of the discs front and back. The other interesting part about the brake system, is not only had it been recalibrated, the hydraulic part, is they don't use brake-by-wire. Now, they have an electric brake booster, obviously, but this is still a traditional hydraulic system. When you push the pedal, you're moving hydraulic fluid into the brakes, so you still get a feedback loop from the system, which is very helpful in extreme driving. We're talking over 8 or 9 tenths, and this is something a lot of modern cars we've driven have struggled with, things like the more modern NSX or the new Z06. When you get on track, it's one of the things that is the most disconcerting because you have no feedback through the pedal. The brakes are very capable, but you just don't feel much. And this car attempts to solve that by keeping a more traditional brake setup. The other interesting thing that they're doing here, compared to other electric cars or hybridization cars, when you push the brake pedal, you're moving hydraulic fluid, there is no brake blending here, no regen blending with that brake process. So it feels far more natural, and a lot of the tuning of this car, from steering to brakes to a lot of that, makes a lot more sense in terms of a driver's car mentality. In the high regen mode, it is able to create 0.3 Gs of force. And that takes a lot of wear and tear off the braking system and also helps during liftoff in high braking maneuvers. So you're offloading some of the brake wear onto the regen part of the car, and you also have the recuperation part of that energy that you're reclaiming. In terms of suspension, Lucid took a different approach here. Unlike many of the longer wheelbase luxury cars on the market that have rear wheel steering, air ride, adaptive sway bars, they chose to get rid of all of that here because of the way that they're able to calibrate their tri-motor system helps to shrink down the car without needing that. Also, to keep it a bit more simple, they've eliminated the extra layers between the driver and the car, and it's more natural for that. So they stuck to a static spring rate setup with adaptive dampers by Bilstein. Now, the adaptive dampers are a higher end unit, but they're able to control compression and rebound independently. They're also able to adjust 500 times per second. And the concept here is to make the car feel natural and ride great on the street. And then also go to a much firmer setup on the track or hardcore driving without sacrificing the ride quality as well and not making the car beat you up. Now, in terms of tire design, this is a big one. And on the traditional Lucid Airs, depending on what trim you get, they're more looking at having smaller wheel and tire packages with aerodynamic wheels, obviously helping coefficient of drag, reducing drag, increasing efficiency. That plays a huge part in improving range on a vehicle. So now you have a high performance car that's kind of throwing all that away. With the exception of the tire choice, when you see Michelin PS4S, you think, okay, we've seen this on other cars. The difference is this is a bespoke tire for this car, and the difference here is the outer shoulder of the tire is a Cup 2 compound. The center portion is a PS4S, and the idea is in that main tread block where you're going straight and you need efficiency, you don't have as sticky as a compound. You have a much stickier outer shoulder of the tire that gives you the grip advantages under that high load. So they're trying to balance the best of both worlds here, again, without having to go through recalibration of a system for this tire, this wheel. They really did try to simplify a lot of this while still making it feel like it does everything really well.
So on regular air, non-Sapphire air, we work with Bosch as a partner for ABS, stability control, traction control, and they've been fantastic, brilliant partner to work with, fantastic system on those vehicles. We've wanted to bring a few things in-house and vertically integrate where we can so that we have complete control over what makes up our vehicles. And this has been a really good example. We started out 18, 20 months ago with a blank canvas, and we brought traction control in-house amongst a few other things, and it's given us like I said, a blank canvas to start from, and we can decide where we want to go and how we get there. So that's been fantastic in allowing us to continue to, we're going to keep repeating the same message of we want this car to be honest and predictable, and for an input that a driver makes, we want the car to make a consistent output, so you get the same behavior. So the driver can trust the car, they know what they're getting.
What do we want the car to do? What can we do with the car? Mixed with referencing of other cars that we like, that other people like, and have more kind of conventional systems. And when you kind of work through these, and you're either thinking of the software, that's the algorithms that are going to go in it, or you're calibrating them, you end up spending a lot of time kind of referencing what would a car with an EDIF do, and how does that behave? And in some ways, there's admirable character from the cars that do that, and in some ways, there's things that those vehicles can't do that we can do. I mean, you know, like a differential, for instance, you can only really open it up if there's not, you know, a significant amount of torque applied. Whereas we can actually take that and just we can regen the inside wheel and drive the outside, even when the driver's not making any torque requests, and that you can significantly alter the balance of the car at all. Different, you know, that feels almost seamless to the driver, like you just put a bigger rear bar in, and so you have a ton of power to be able to kind of adjust the vehicle in the different modes, and depending on what the driver is doing. And then sometimes you wish you just had a good old-fashioned clutch between your two motors. I mean, it is an inherently simpler system, and there's a lot of times where, you know, we had to go calibrate the car to feel like it had a clutch in certain areas at high speed or you know, on certain surfaces and maneuvers. Yeah, but it was kind of an opportunity to create what we think a 3-motor application EV should feel like, and at the end of the day, we're fairly proud of it.
And to continue John's point, early on when we started developing Sapphire, we had a lot of conversations around the team about what do we want to make here, because it's such an open-ended question. We can make whatever we want to make now, because the technology has moved on to the point now where we don't have to deal with the same constraints. And previously, constraints may have shaped what the product ends up being. Now there's this huge question. So we had a lot of conversations, and a thing that came up a lot is our love for big V8 super sedans. And this guy drives one every day, Chevy SS, and we've got a couple of E39 M5s in the team, which we've talked about as a reference for non-Sapphire Air before. But for Sapphire specifically, we did a long-term rental of 2 of the cars that are kind of seen as the leading super sedans. So we rented an M5 CS, BMW M5 CS, and we rented a Cadillac CT5V Blackwing. And we loved both of them, and fell in love with both of them. We wanted to kind of cherry pick certain attributes from each of those. We loved the M5 CS so much that we didn't give it back at the end of the rental, and we bought it, and it's on our benchmark fleet here. But those 2 cars have been a constant reference for the development of Sapphire. And something they do very well is this. They do it well because they have a big V8 front-engined rear-wheel drive, or in the case of the M5, all-wheel drive setup, where you've got that kind of inherent inertia to the system. It's playful, but it's not spiky. It doesn't catch you out. It's very smooth. They are great cars to throw around, but then they're also great cars to spend several hundred miles in a trip in. and several hours in. So we've tried to bring a lot of that into the Sapphire through our tuning and development, whether it's powertrain controls, whether it's damper tuning, whether it's steering tuning. And we'll see what you guys think, but hopefully there's a bit of that flavor in there.
So for us, torque vectoring means anytime you're moving torque from one wheel or one axle to another to affect vehicle behavior in some way.
So traditionally, torque vectoring is either done by brake, like it still is in the front of this vehicle, or through mechanical clutches. How are you achieving torque vectoring through two separate electric motors? And the big thing that makes Sapphire different than a regular Lucid Air is two electric motors in the back that are independent of one another despite being in the same physical housing.
So for our electric motor torque vectoring system, we can put positive or negative torque on any given wheel at any given time. This allows us a ton of freedom because we can sort of overdrive one wheel while we drive another wheel backwards. We can shift the entire torque balance from one axle to another. And we can do all of this really quickly and really seamlessly in a way that maybe a brake-based torque vectoring system couldn't do.
Vehicles generally want to understeer at lower speeds, especially a long wheelbase car. But with this, we can really kind of shift the mechanical balance and raise the effective yaw rate gain of the car down at low speeds, and then fairly seamlessly without running pumps and generating heat in the brakes, shift that to more stable at higher speeds, and also and then vary this if you go and change your drive mode or your stability control mode. It really just blends in with kind of the character of the car and adds that kind of extra dimension that you just really can't do through a standard differential system or with brakes.
The particularly unique thing that three-motor torque vectoring allows you to do is shape not only the limit behavior of the car, but also the sublimit behavior of the car. On a normal, all-wheel drive setup, you can kind of shift torque balance front and rear at the limit, and that can affect the lateral behavior of the car significantly. But you can't affect the cornering balance below the limit quite as easily. When you have three motors, you can torque one up and torque one down, and that gives you this sort of extra special turn-in feel, even way below the limit. The really cool thing about that for us is that it allows this car to be different and special and physics breaking, even on sublimit mountain road driving. If you're driving at maybe 5/10, it still feels really different.
How do you blend the technology of having three-motor torque vectoring with the stability and traction control algorithms that you guys have written, with also making this feel like an organic car? Something that Mark brought up earlier was making a vehicle like this, which is all electromechanical systems, all technology, make it feel like a car that you or I, that I know you own, like driving on the weekend. How do you blend the technology into making it feel like an organic experience?
For me, there are two different things that we look at here. First of all, blending each of the different systems with one another is really important. Traction control and torque vectoring share a lot of the same directions in this product. So it pretty seamlessly blends from torque control to slip control, depending on whether you're kind of below, near, or beyond, in your case, the limit. So that's the first one, is making sure that all of the different systems on the car are sort of beating to the same drum, if you will. The second one is that we sort of had to think outside the box a little bit in terms of classical control design. There are a lot of things that you do in first controls class to control a system that really aren't what you would want to do on a car that also has a driver behind the wheel. The drivers are controllers too, and they have to control the car, but they do all sorts of wild things all the time. And so you want to make a system that works with them, not instead of them, and not especially against them. On the original Air, we had Bosch, our chassis control supplier, supplying stability control and traction control, and then ABS and some ADAS support functions. We now, because torque vectoring needed support from a more reactive system in-house, we took over traction control. Bosch still supplies stability control for us, but we're able to use the torque vectoring and traction control to try to manipulate the vehicle in as many different cases as we can so that we can push out the need for brake-based stability control interventions so that we can lean more on these systems that are smooth and like seamless and you kind of don't know that they're there and just make you feel like a hero as a driver without having to hear the stability control pump run and have an abrupt intervention.
We again kind of referenced some of the classics of, I'll say, predictable. Well, yeah, debauchery. Right. The cars that make us smile when driven sideways. I think we couldn't find that same character out of any electric vehicles that were currently on the market. I think a lot of that is because of the inherent inertia properties of EVs. You know, a lot of times all the mass is in the center. The yaw inertia is quite low relative to the wheelbase and the overall mass, so you get kind of quite snappy breakaway behavior. And again, on the motor side, I mean, instead of a big V8, if we keep going back to that, you know, you have especially in our case, you have a tiny electric motor that's able to spin the wheels up to 200 miles an hour in our case. And I'll say that a lot of work went into making that feel, the transfer function between the throttle pedal, a vehicle breakaway, how it moves, how it recovers, how it responds to your input. We did a lot of work to make that feel how we think it should feel for electric vehicles going forward. And we're really excited for you to demo it yourselves.
Jack, we learned everything you need to know about this car and then some, but how does all of this actually work in reality? Well, it works in one of the most alarmingly capable and fast four-door vehicles I have ever been in, regardless if it's internal combustion or EV. We are in endurance mode to have a little more longevity here on track, so it makes a little bit less peak power. And as we found out earlier, this car is faster with not all of the systems fully off. Yeah, you have to leave it in track mode as soon as you disable stability. It gets a little bit too loose, although more fun, but it really does cut in your time. So the reason is, and this is really the big part about this car, is the dynamics. The people that have worked on this have spent an asinine amount of time trying to figure out how to transform an electric vehicle of this size into something that is more reminiscent of older internal combustion car characteristics. It's a combo of making it feel really natural, which it's hard to do when you have a tri-motor setup like this. You have two, motors in the back with torque vectoring. You have a motor in the front. So getting those two to talk to each other seamlessly and transparently to the driver is a lot of work. The way that everything communicates with each other is so instantaneously. You're doing communication over Ethernet versus CAN bus, so everything has this sharpness, this crispness to it, even that a lot of the electromechanical systems that we find in internal combustion cars that have been perfected, this has literally no delay. And there's little details to it. There's nuances that you get out of it that I appreciate so much for it being such a huge car that it makes it feel like a more nimble sports car. Like under braking, if I lift and coast, the regen braking is pretty aggressive to the point where it transfers the weight so much to the front that it lightens up the back to get you through the corner. And if you start to understeer a little bit, all you have to do is lift out, and the combination of that outside motor hooking up and the regen braking makes this feel like it has rear steer. And they've done all of this with traditional dampers, with traditional sway bars, and without all the trickery of a lot of the internal combustion
and without
cars.
Sacrificing NVH to the point where it's not still a big luxury sedan. on long highway drives. It's that do-everything approach to this car, which normally doesn't work, but somehow, through the magic of engineering and all these gentlemen and women talking in this video, they've turned this into a really remarkable four-door driver's car.
Yeah,
the one thing is you can't fight the mass.
You can't fight the mass, and that's kind of the fine print to it, even though you have these enormous brakes which never give up, hydraulic brakes, so it's really natural. You're stopping a lot of car, and you know, it really out here, granted this is not a pure track car, within 2 laps you've overworked the tires. I mean, you can run them off so fast, so you have to be very careful. And you know, we're in endurance mode right now because that's how you run a full session, which limits the power. But if we do switch over to maximum attack, hot lap, you're getting the full 1200 or so horsepower, which from our testing in the heat is really good for 1 to 2 laps before it's really trying to pull the power to keep the battery thermals in check.
But even with 1200 horsepower, it's not unmanageable. You really appreciate how they prioritize the outside rear tire when you're leaving a corner to sort of help yaw this thing out and stabilize it a little bit with the front brake.
Yeah, this is the first car I've been in. I mean, this thing is just unbelievably fast in the straight line. It's not all about straight line performance. I thought going into this 100% that, okay, we're gonna go flat out in a straight and then this thing wouldn't turn, and it's completely the opposite. If you're in the window where those tires are working, it's unbelievable how much the front end and the back end work and how much the torque vectoring in the rear pulls you through corners. Oh my God.
Mark, all this technical and clean driving talk is getting boring. Something we haven't done yet is experience what it feels like to launch this puppy and misbehave.
God, dude.
So everything's off, and honestly,
what does that mean?
That is how you should be driving this car.
Oh my God. Holy shit.
Oh yeah!
Oh my God.
Oh yeah, on the ground!
Oh my God. Oh.
Oh,
Don't do it here, don't do it here, don't do it here. Oh. Oh. Oh my God, bro.
Oh yeah.
Oh my God.
Oh, yeah. Now, Mark, let me tell you, that's what I want out of my 1200 horsepower super sedan. I want big skids. Big skids. Oh yeah.
I got big skids in my underwear.
It's amazing how easy it is too. It just wants to do it everywhere.
Oh my God.
Oh man. Oh man. Oh man.
Oh my God.
Yeah. Oh yeah. All right, Mark.
So that's all you do in this, great.
So with that, Mark, I think it's time for us to head into the final thoughts. Final thoughts on the Lucid Air Sapphire. First off, huge thanks to the Lucid PR team, the engineers, management, and of course, Autobahn Country Club for giving us a home to make this video. The Lucid Air Sapphire is one of my favorite cars I've ever driven and is easily my favorite four-door vehicle. The level of joy it gives me and the ability that I can make Mark sick and of course set a blisteringly fast lap time does not tell the complete story. It's the fact that there's a level of joy in this car, and that comes from the people who make it. The engineers, the team behind this product love cars and don't want EVs to be the death of automotive joy and automotive love.
I think that's an important point, and there's some fine print which we're going to get into. I wanted to say, driving this on track, even with Britt Casey behind the wheel, when you turn all these systems off and you're at a full charge, battery conditioning, and all the parameters are right, this is the closest we've ever came to crashing a car. Like, literally, it is insane. And I think that if you have that accessibility to that power level, you better be pretty responsible. Now, all of the driving that we did, we talked about a lot of the stability control systems. What I think is most interesting about this car is the vehicle dynamics people and the management made a clear decision in its tuning and its setup that they were looking at internal combustion cars, sedans, like cars that you love, like the CT5V Blackwing and the M5 CS, these super sedans with internal combustion. They were trying to build some of the heart and driving character from those cars into this. It wasn't just about spinning up a couple electric motors and making it go fast. And that's partly why this was such a
package.
It is. It's a complete package. And I think it really does speak to you, somebody that wants to obliterate tires and go sideways, which you did more than my fair share of what I would have liked. But I think that's why you loved it so much. But what I really appreciated, and as I sat with the vehicle dynamics engineers with this and talked through some of the data points and how they did this and developed it, I think the surprising point was also that when you were using the systems as they were supposed to be designed, not just trying to go sideways everywhere, that it did behave like a much smaller vehicle without all of the insane technical systems, air ride, rear steer, and all the other things they probably could add on later that will make it even better. But to shrink this down to get what they got out of it was nothing short than miraculous. And they continue to work. As we were sitting there driving this, they were still continuing to look at data. How can they make tweaks? How can they make it better? And all of this learning from the most extreme car that's pretty much on the planet of this type, all of that's going to transfer into their future vehicles. And obviously most people aren't going to need that in an SUV. But that dynamic discussion is a clear part of why I love this car so much, but there is some fine print, Jack. And to be fair, Lucid knows this. Everybody that's in the electric car world knows this. We had two cars there. It was extraordinarily hot.
108 degrees the first day we were there.
Yeah, first day. And it's really rare in Illinois. But let's just say, you're in a hot climate. This is what you're going to experience. And because Autobahn does not have DC fast charging, they had to bring a generator truck, DC fast chargers, to keep these cars alternated in terms of charging them. And not only that, battery conditioning played a huge part in this. It wasn't just like, hey, we're going to go out and run all day and go fast. You had 1 or 2 laps of full-blown power before the battery conditioning was at a level where the cells were starting to get too hot based on their algorithms. And I know you spoke with the vehicle dynamics engineers about this as well.
So the reality is the batteries in these vehicles, their happy place really is 20C. And they have a bogey number between, and this is the same for basically all batteries,
yes,
between like 50 and 60C. And when you're sitting at an ambient temp of 110, your saturation point for the cooling system for the batteries, not the electric motors, is going to be a problem. Under better circumstances, like when they've done all their testing in VIR, when they run this endurance mode, which is more like 900 horsepower, which is still faster than you could possibly imagine, the car can do 7 to 8 laps on the Grand Course, which is very impressive. But in our experience, which again, any car, even internal combustion vehicles, at Autobahn, which is particularly hard on cooling because you don't have big straights, you got 1.5, maybe 2 laps before this car throttled back its power.
And that fast lap was set under those conditions of trying to run a lap or 2 laps and then backing off, letting the battery conditioning come up, letting that temperature come back down. So it's not like taking a Porsche GT3 or your Z06 out there and running a 20-minute session and your limiting factor is your tires falling off or maybe losing some brake efficiency. this car and almost all electric vehicles of this type are going to suffer this with cylindrical cells until there is a breakthrough in battery technology and thermal technology. Now, they did tell us when they worked in Formula E that they could probably have taken the battery pack technology that was more resilient to heat and put it in a car like this, but it would also evaporate half the range. So they were trying to build a car, and the Sapphire specifically, that found a balance. Could they have done stickier tires? Yes. Could they have built a more aggressive battery pack and thermal conditioning for those batteries where they would last longer? Yes. But the core of this was, it was a street car. Efficiency is always at the top of mind. So they were really trying to push this towards the efficient direction. And I think the interesting part of all of that is it still works. As a street car, this is an unbelievable experience that cannot be explained. And for me, if I was in the position to buy a car like this and I wanted it, I would buy it purely out of the principle of I want to support them to see what they're going to be able to do next. And sometimes buying products are like that. For many people, you want to support their mission and their values, and that's what I felt like walking away. I would literally buy a Lucid just so they had enough money to get to the next car to see what they did next, and that's really rare for me. And I bought cars for that reason in the past, and I would consider doing that in the future.
I think the thing that speaks to me is not only do I support their vision of what the future is for cars, but it's actually a good car.
Yeah.
And the duality of something like the Sapphire is something I have not experienced. It's a very controllable car with all the systems on or in their fastest mode, which is their track setting. And when you turn something off, it's a complete monkey. You're on your own in the best way possible. I've never experienced a car that can be a GT car, a true GT long distance car, a very capable track weapon, and of course, something that you can kill yourself in if you're not smart.
And I 100% agree with that. I think that's the interesting part about this car is that it can do both the fine print, of course, on a hot day and all that with managing battery thermals. But the other part is I promised that I would not get political in this video and get into the philosophical debate of like what it means for the future and all of that. And I'm not going to do that. What I will say is, and I told this to Lucid, honestly, and I think they agree, is as great as the Sapphire is today and the Air is today, it's still a first generation product. In 10 years, once battery technology flips and you can double the range or shrink the batteries down to 5 modules instead of having 20 and still have the same range, we're not going to be talking about the Sapphire. It's going to sit in a museum and like, look what they did. So as of today, it's the best of what you could possibly achieve with the engineering and technology that we have, but they are pushing it forward and it's right there. It's right there. This is enough to buy. Like, you know, we've talked about electric cars that I'd be like,
I'd buy this one.
I would buy it and I'd support them and buy it and wait for the next one or lease it at least. I think it's that good.
I mean, I think we're at a really early stage still of the transition to electrification. You know, you have predominantly still early adopters or kind of fast followers getting into electric vehicles, but the infrastructure still needs a lot of work. You know, there's a lot of growth and expansion that needs to happen before it really becomes truly mainstream and that broader over 50% transition happens. But I think it's accelerating and it's going to get there, but the infrastructure has to get built out. And it's not unlike when we transitioned from horse and buggy to, you know, gasoline vehicles. Before there were even gas stations, people were buying fuel from the drugstore, you know. So we're much farther along than that, but it's going to take some time. I really feel there are certain things that the electric vehicle can't immediately replace. There's just certain applications where the internal combustion technology is still totally applicable. I personally believe over time that electric technology will grow to the point where it's just the logical thing for most forms of mobility. Most. Again, I can't predict the future, but I look at how quickly this is evolving, and I think that there are certain things that I think will be overcome. Once the infrastructure's there, it'll be able to be applicable across the board. But we're not there yet, you know. Also, I think that the broader spectrum of vehicles currently available to the market aren't for everybody. There isn't an electric vehicle to meet everybody's needs at the moment. So of course, there's consumers that are not there yet. They're skeptical of the technology, and that's fully understandable. But I believe the market will adapt and will provide solutions for most mainstream consumers over time, and that's again to further the hope that we can transition most of the market to electric. Of course, I love cars. I love all kinds of cars, and I still have my own internal combustion vehicles. But I think there'll come a day where that's purely a nostalgic experience for most applications, and I think the technology will get us there.
Where I see, that performance, how we make performance more affordable. Imagine you have a $30,000 vehicle, but with the Lucid Air, or sort of close to the Lucid Air performance. That's our goal. It's like to make that product so desirable, but at the same time cost effective. And I think that cost effectiveness is something is going to evolve and improve significantly. Secondly, the battery side, we see lots of evolution in the battery chemistries and the manufacturabilities of the battery, which would reduce cost, and the system integrations. But EVs are still in their actually early iterations. Architectural wise, you can see the Lucid Air, how it compares to others. It's a huge step in terms of improvement and innovation. But there is a next step, and depending, of course, on your priorities and what volume or targeting, you could focus on certain aspects of attributes, either cost or performance or efficiency. But I think the efficiency will evolve significantly. The battery chemistry, the energy density, power densities. One thing sometimes, if you think about high performance EVs, are criticized for is the thermal endurance in the track. That's something will be addressed in the coming years. We'll see EVs which will do multiple laps in Nürburgring without problems, and you will see vehicles would do 300, 400 miles of range with a much smaller battery, which allows us to basically having that multiplier effect on the planet and the wallet.